All right, can you guys see? You see the bighorn sheep? Will they survive? Big. Okay. All right. So we have a population of bighorn sheep out in Rocky Mountain National Park, currently under protection by the Colorado Fish. However, more recently, biologists have been concerned about whether the sheep will continue to grow in numbers in the future years. They know that this is highly dependent on the birth rates and the survival rates of sheep at different stages in their lives. So this information can be described in a table. Like I said, just follow along. You don't have to write any of this down yet. So for these problems, you're going to be given a table for whatever we're doing the population of. This, it's bighorn sheep right now. And each stage of their life, you can see it's in 2-year periods. So those that are from 0 to 2, those from 2 to 4, 4 to 6, up to 10 to 12, which means this is the end. Nobody's going beyond 12 years in this population. So they're going to be anywhere from 0 to 12 years old. The birth rates are saying that if your baby sheep, the 0 to 2 year olds, they're not having any babies themselves. But once they turn 2 to 4 years old, about 80% of them, or 4 out of every 5 of the sheep, will have a baby. When they're 4 to 6 years old, they're actually accounting for more than one baby each. So each one of them is going to have 1.6 babies on average over that time. And I know you can't have 0.6 of a baby, but that's for all of them, which 1.6 is 1 3/5 or 8/5. So that's every 5 of those sheep will account for having 8 babies. So some of them are going to have 2 within that 2-year period. And then 1.4 and so forth. Then these guys, they're just having a few babies. Survival rate is how many are going to make it to the next stage. So 60% of the newborns will make it to be 2 to 4 year olds, and 80% or 0.8 will make it to 4 to 6 years old, so forth, 90%. And then the survival rate of the last group will always be 0 because none of these guys are going to make it beyond 12 years old. So when we talk about cycles with this, it takes, because they're in 2-year groups, it's going to take 2 years for each cycle to go through, right? Because if we talk about what's happening in 1 year, well, the newborns won't be out of this group yet. So we have to talk about 2 years later. As long as we talk about 2 years later, everything will cycle through. So if you're 4, then you'll be in this 6th group. If you're 5, in 2 years, you'll be 7. So you'll be in the next group. If you're almost 6, so forth. All right, then we need what's called an initial population. So if you add all those up there, 420 sheep, and this, it's really about the female sheep, but I always leave female out when I'm typing these up, but it should say female sheep. But there are 20 baby sheep, right? 20 of them are 0 to 2 years old. In this population, 40 of them are in that age group. So this is just, it's a distribution. It shows you each age group listed out. So based on that and that table that we have of how many are going to survive and how many are going to have babies, we can predict the population in 2 years' time. So let me show you. Turn on my pen. All right. So first off, and remember, this was to start out with 20, 40, 60, 80 of these guys, 100 of these guys, and 120. So in 2 years, the babies are going to come from all of the ones that had babies out of these groups, right? And that's the birth rate. So like those 20 are not going to have any babies at all because their birth rate is 0. Those 40 are going to have 80% of them are going to have a baby. So 40 times what? 32. This is 32. So this group is going to have 32 babies, and those will all be 0 to 2-year-olds. Doesn't matter what age of the sheep that they have the child, all the children will be in that 0 to 2 years old. So these 60 will have 1.6, and you can go to Desmos, multiply that, or use your calculator. I have a calculator somewhere.
Close by.
60 times 1.6, so they're going to have 96 babies. And the 80, you're going to have 1.4 is their birth rate. So 80 times 1.4, they're going to have 112 babies. And those 100 are going to have 80%, so they're going to have 80 babies. And the 120, 40%, they're going to have 48. So altogether, all of these newborns, the 32, 96, 112, 80, and 48, 368 total, are all going to be in our 0 to 2-year-olds, because in that 2-year period, doesn't matter if they're born the first day of it or the last day of it, they will stay in that 0 to 2-year-olds. So the 2 to 4-year-olds, those come from these guys, right? In 2 years, they're going to be the 2 to 4-year-olds, but not all of them are going to survive to make it there. Only 60% of them. So you're going to have to do 20 times 0.6. So only 12 of them will survive and make it to the next age group. And of the 40, only 80% of them survive. So 40 times 0.8. 32. Those 60, only, or 90% of them are going to survive. So 60 times 0.9, that'll be 54. Those 80, 0.9 again, right? 0.9 survives, so 80 times 0.9, 72. 100, 70% of the 8 to 10-year-olds. So make sure you're looking at the survival rate for this group, the 70%, for the 100 to move on. So that's 70 of those. And then the 120, sorry guys, but none of those survive. So we don't have to worry about the next group. So there's your new distribution. The total population would just be add up those numbers, 32, 54, 72, 70. So now there are 608 sheep in that herd after 2 years. So questions on that? Does that make sense where all those numbers are coming from? Okay. So I'm going to have to, hold on, let me write these down real quick. So that was 3, 6, 8, 12, 32, 54, 72, 70. So if the question is, how many will there be in 4 years? Well, that's just another cycle. You're cycling through one more time. So the After 2 years, we had 368, 12, 32, 54, 72, and 70. So now, babies, none from them. The 12 have 80%. Those 32, 1.6 is their birth rate. For the 54, it was 1.4. The 72, 80%, and for the 70, it was a 0.4. So I don't have to do all that individually. I'm just going to do it all together. I don't also, if it's 0, there's no need to put that in the calculator. So 12.8 plus 32, 1.6 plus 54 times 1.4 plus 72.8 plus 70 times 0.4. That is 210. That would be 210 babies would be born over the next 2 years to get to the 4-year mark. And then how many survive? So the first group, the survival rate was 60%. So 368 times 60%. That's a decimal. Go ahead and round to the nearest whole sheep when you have decimals. So it'd be it's 220.8, but you'd use 221. These 12 have a survival rate of 80. The 12 times 0.8, 9.6, so just 10. 32 times 0.9, 28.8, so 29 of those. 54. 90% of those guys survive, which will be 49. Then 72 was 70%. 50.4, just 50. And of course, none of those survive. So that would be the next group, and then I could add them all up and get the total again, right? So I can't, the way I'm doing it, I can't find the 4-year total until I get the 2-year total. Then if it asks me again, if it wanted the total in 6 years, then I have to go off that 4-year total, which I didn't write it down, so I don't know it. But you get the idea. I have to take these numbers and put it all through that again. So if I ask you, how many deer or how many sheep, sorry, are there going to be in 12 years? Well, it's going to take so many cycles. And the big thing before we start the matrices is understanding that if I say how many deer are 12 years, that's 6 cycles that it would go through, right? If I said how many deer or sheep, how many sheep are there in 50 years, well, it'd have to go through 25 cycles because each cycle is 2 years long. So that's an important part of setting up these matrices. So let me show you how that works. First, every time you're going to have an initial population and you just set up what's called your P sub O, this is the initial population of the deer. And it's just a 1 by however many age groups there are 6. So it'll be 20, 40, 60, 80, 100, 120. So this is where, if you're taking notes, you'll want to write this down. So this is called your initial population. It's always going to be a row, however many age groups. Luckily for you, Desmos doesn't go beyond a 6 by 6 matrix, so I will never go beyond 6 age groups. Also, good time, remember, one cycle equals 2 years, or 2 years takes one cycle? So I'm going to multiply this 1 by 6 times another matrix so that I get a new population distribution, a new 1 by 6. Anybody know what size this matrix has to be to make that work? Remember, they have to match, so this has to be a 6, and then a 1, if I want a 1 by 6. So I have to make a 6 by 6 matrix. So this is where that Leslie population is coming from. So this table is going to be used to make what's called our Leslie matrix. I'm just going to call it matrix L. And since I have 6 age groups, I have to do a 6 by 6 matrix. And it will always be square. The first column is very easy because that's your birth rate. That's your babies. Because if you have this population distribution, right, you got each one of your age groups. Remember, we multiply row times column. So you want to multiply the babies. How many babies are they going to have? Well, none. How many babies are the second group going to have? 80% of them. And then 1.6, 1.4, 0.8, 0.4. So each one of these would multiply with the right percentage of babies they have, and then it adds them all up. And that would drop into the first row, first column in our new one. Well, for the next column, which would be, the answer, I'm going to be here in our second column, right? Because I'm going to have 6 answers again. We want the number of the babies that survive into the next group. So if you want it to multiply with the babies, the first group, and that's their survival rate, that would be 0.6. But you don't want anybody else in that column because everybody else is moving out. So they're all zeros. You don't want to multiply any of the other numbers. You just want 60% of those babies to move to the 0 to 2-year-olds. Next, you want the 2 to 4-year-olds to move up to the third column. So you don't want any of the 0 to 2-year-olds. You want 0.8 of the next group and none of the others. So you can see it's forming this diagonal of survival rate. So the next one, you don't want any of those, but you want 90% of the next group. None, 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 90% of that group. None, 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 70% of that group. And then the 10 to 14 or the 10 to 12s, they're done anyhow. I don't want to add an extra column because that would make 7. So this often bothers people. This diagonal does not end in the corner. So a lot of people want to make it end in a corner and it doesn't. It's like watching the thing move around on your screen, waiting for it to hit perfectly in the corner. Not going to do it. So this is your survival rate diagonal. So the nice thing about, what time is it? I got time. So if we open up Desmos, you want that matrix calculator. Right, start with your population. It is a 1 by 6 with 20, 40, 60, 80, 100, 120. Your L matrix, so we can just leave it B. You can name it L if you like, does not matter. But I'm going to do birth rates going down. So 0, 0.8, 1.6. I think I put a comma there. 0.8, 1.4, 0.8, and 0.4. And then survival rates go diagonally. So it's 0.6 down and over, 0.8, 0.9, 0.9 down and over, 0.7. Like I said, it's not, you don't have to type over the other zeros. They will stay zeros when you put that in. So this is where the cycles become important. Come back here. You guys see this, right? So if you want the population distribution in 2 years, you will take your initial population, and 2 years is 1 cycle. So you would raise this Leslie matrix to the first power. That's 2 years. If you want the population in 4 years, that is 2 cycles. So if you want the population in 10 years, you would take and do it to the 5th power, because that power is always the number of cycles. So you don't have to, with this, A times B, that gives me that first group we got, the 368, the 12, the 32, that's 2 years later. But if I want 10 years later, A times B to the, so it's here, that's the power button, to the 5th power, I don't, and just like I said, round these to whole numbers for animals, but I don't have to go through every cycle to get to 10 years. So this is the nice part about the matrix. It just keeps on, because if you think about it, A times B, that's 2 years, and then we took that answer and multiplied it times that same stuff again. So that's 4 years, and that's 6, 8, 10, so forth. So you can just raise that to the 5th power, same thing. The only other thing, Drew, that you need for this is sometimes it will ask for a total. What's the total number of sheep after, say, 12 years? So I'm just going to call it a T matrix, but anytime you want to total a row of 6 numbers with matrices, you can do a column of 1s. That way, if you have this row of 6 numbers, each one would multiply by 1, not change them, then I'll add them up. So a column of 6 ones. So if I do a C matrix and make it 6 by 1 and all ones, then if I want to know what's the total amount of sheep in 12 years, that would be A times B to the 6th power for 12 years, get out of the power, times that C matrix will total them all up. So you're going to have 1,533 deer in 12 years. So how many deer or how many sheep are there in 20 years? A times B to the 10th power, 20 years, times C. So there's a total of 4,052 sheep in 20 years. All right, so the big thing is setting up that Leslie matrix. So, if you look at the assignment, it's just a one problem assignment. There's your 6 different age groups. There's your initial population for the 6 age groups. Write that as a population matrix, like I showed you. Show the table in a Leslie matrix form, birth rates and survival rates. And then this one, their age groups are 3 years. So one cycle will be 3 years. So if I ask you how many will be around in 15 years, then that would be 5 cycles. So make sure now it's in cycles of 3. So use that, do your 3 years. Don't do it the way by hand, do it with the matrices. 6 years, 15 years, and then here, what's the total population after 20 years? That would be to the 7th power times that column of 1s. It'll give you the total. Same thing for 30. So it's all based on one problem to try out. We'll go over that tomorrow before we do a little bit more with this. So